we might get there. If there's too many college algebra types in the class, we might not get there, but I don't think so. I'm not sure who signed up. Who is? You. That's it. Okay. I can count. We'll get the conformal mapping too. That's great.
How many math majors out there?
50. Some people I never know. I don't know who the hell they are. Somehow, some of them even escape our seemingly. What? You can't avoid it. Well, you know, I like Heather Acton. I think she had me, I guess, of ultimately 2 courses, but I didn't even know who she was until she was a senior. But she was a math major. And I don't think she transferred in. I think she came up from the minor leagues. Anyway. So what were we talking about? Linearity of the steel just. So how would one approach this? Well, what do you have going for you? You know that the limit of sum is the sum of limits, the limit of the difference is the difference of limits. And these integrals are really limits of sums, you know, big sum, right? Still just sums. So maybe that would be the direction I think I would go. If f and g are separately Riemann still just integrable with respect to alpha, it must be that there exists the partition P1 in the family of partitions on AB, such that what? Let's fix epsilon. Well, can we say this? Can we say this? That if I fix epsilon in advance for all time, there exists a delta 1 of epsilon such that if P1 in norm is less than delta 1 epsilon, that implies the absolute value of this Riemann sum is due to some. So if the norm is small enough, when I do the Stieltjes sum, it's pretty close to the Stieltjes sum. And they're also, in fact, why don't we just make it epsilon over 2 already? And then there's also a delta 2 of epsilon, such that if the partition P2 has norm less than delta 2 of epsilon, it implies a similar result for P2. So we're going to make that a J, right? Minus the integral from P. This is pretty dumb. This is G. I used G. So F is integrable gives me this. G is integrable gives me that, right? Yep.
Why did you change to go to? When I was doing the proofs on the terms, a lot of times I was like confused if I should use the E or the 2.
Okay, here's why. Or I wouldn't have to. Berg is really bad about this. Berg will start out and fix epsilon, and then he'll get something that's less than epsilon times, say, b minus a, well, something else. And he'll say, therefore, it's arbitrarily small and must be 0, and makes a conclusion. Nothing wrong with that. If you're writing a textbook, usually what you'd like to have is some argument that works out so that it's less than a particular epsilon. It's just cleaner. So you can see where I'm going. I'm going to make this less than epsilon over 2 and this less than epsilon over 2. So the sum of these two things will be less than epsilon.
Okay.
I fixed epsilon in advance.
Okay.
That's the only reason.
Because you're gonna add those two together.
I'll tell you this right now. You can always say, if you fix epsilon and you work through a problem, and then you get some expression is less than or equal to 10 epsilon plus c, which is some constant times epsilon squared. Burke would say, okay, that's enough to show that it's 0, this thing over here, right? Because epsilon is arbitrary, so this is arbitrarily small. The only way out is for this to be 0. Or you can do this, make it epsilon prime, and say, you know, it was epsilon prime that I meant to be greater than 0. You sort of go back and fudge it at the end.
Makes sense now. I just
That's why
catching
people do
that
that.
little thing why it was epsilon.
Well, it's an art form to pick the right epsilon. But you can see in a simple case like this, we're going to add these two things together, and then to the triangle inequality, what we'll do is construct the common refinement, and then we'll be able to say that these things are both still true for the common refinement, right? Yeah, planar partition. It can only it still satisfies both of these things. So we will make a partition that is mutually smaller than these. Okay, so we just unify all the points in P1 and P2. Certainly this will happen, and this will happen too. So it will be less than either one of those. In fact, I'll call that delta. Might as well do that now. I mean, that's what we're doing. So we have these two things. So let delta of epsilon be min of delta 1 and delta 2. Okay? Then consider every time I say that word, I think of Monty Python and Life of Brian. And he says, in a falsetto voice, consider it. They're building some religion around it. Okay? I'm sorry. I always do it. But I digress. You know, Einstein's definition of insanity, doing the same thing over and over again, but expecting a different outcome. I've switched pens now, back and forth, trying to get a better pen. So apparently I'm over the edge. It's not getting any better.
Is it getting any worse?
No, well, I don't know.
I
wonder if there's something, if I take out, I noticed I've cracked some molars. I have a tendency to clamp my jaw down for stress. And now I've got this thing with these fine point pens, I bend the nail out. Then I have to turn it over and pull myself down so I can write. I wonder, some kind of unconscious stress. Have you done that? Just you need anger management style.
You know what I still do sometimes with those whiteboard markers? Staff report, emphasis and they go.
Oh yeah, that's not good. That's not what happens to these.
That's right. Circular file.
I know, I practice basketball.
So, let's see. Let's build a big thing here. If we have P1 union P2, and what do we need here? F of xk delta alpha k minus integral from A to B of f, we're doing it for the plus case this time, f plus gd alpha. I guess I better add x over, or g over here. So we start over. Sorry, I know that this.